Let me try to explain why vectors are very useful in mathematics and in real life via some example. So suppose we have a boat and we're trying to cross from this side of the river to our house. If we want to end up straight across where the dock is. The river is flowing at 4 miles per hour and our boat can do 8 miles per hour, and we are just trying to navigate in a straight line. Now, if we were going to just go straight to the dock, the river is going to pull us, and we're going to end up somewhere here. And suppose there is, I don't know, wildfires here. We don't want to end up there. We want to end up exactly at the dock. So we want to aim in some direction that way, so that at the end, we end up with, taking account the current, we end up floating or navigating exactly and end up at our dock. How do we figure out what angle should I navigate so that I end up exactly going south to north straight to my dock? Let's figure that out. So this is a problem that vectors can solve. So what we have is a vector, which is the water current. Let's call it A. And we have another vector, which is our boat direction. So here is my vector B. And what I want is for the sum of those two vectors, these are two velocities for the boat, and the sum of the two velocities, I hope that it ends up being just a vertical direction. So what I have to try to figure out, let's call that C. I want for my vector A plus B to be exactly equal to C. That is just the sum of the two. And then we want this vector to be vertical. So let's put some coordinates to these vectors. First of all, what I know is that the vector A is going to the left. So it's going west by 4. So it is minus 4, 0. And what I want is my vector C to end up being vertical. So what I want is that the vector C is 0, and then some other direction. I actually don't care how fast I'm going in the south to north direction, how fast I'm going. I just want this coefficient to be 0, so I know it is a vertical vector. And now, what are the coordinates of the boat velocity? Well, I don't know those, but I'm going to try to figure out. And in fact, what I need to figure out is what is this angle, so I know where to go with my own boat. So let's try to write that in coordinates. The information I do have is that the boat goes at 8 miles per hour. So the magnitude of the vector for the boat is 8. So if I decompose my vector B, here is B, and I want to know what are the components, what are the coordinates of this vector, then, well, from trigonometry, I know that this length will be the length of B times the cosine of the angle theta. And from trigonometry, I also know that this length here is the length of B times the sine of theta. So now I know the coordinates of my vector B are the length of B times cosine theta and the second coordinate, the y coordinate, is the length of B times the sine of theta. I do know what the length is. It's 8. So this is 8 cosine theta, 8 sine theta. And what I want is for A plus B to be equal to something of this sort. So let's write that down. I want A plus B to be of the form 0, C2. I know that A is minus 4, 0, and I know that B is 8 cosine theta, 8 sine theta. So for that to be true, for this coordinate to be 0, what I want is these two coordinates. This adds up to the vector minus 4 plus 8 cosine theta, comma 0 plus, so 8 sine theta. Again, I don't care really about that coordinate. What I want is this to be 0. And that will be 0 when minus 4 plus 8 cosine theta is 0. And that implies that, well, cosine theta is, let's see, it will be 4 divided by 8, which is a half. And what angle has a cosine of a half? That is 60 degrees, or pi over 3. So this tells me that theta has to be 60 degrees, or in radians, that is pi divided by 3. So the answer is that the angle that we have to aim our boat at over here, this angle here, the angle itself should be 60 degrees.